All right, on this handout, we have a series of boxes, and we want to find the acceleration of each one. Now, why do they accelerate? Well, Newton said the sum of the forces on an object, if it's not zero, you get an acceleration that depends upon the mass of the box, of course. Larger masses will tend to have smaller accelerations, and smaller masses will get larger accelerations. In fact, you can write this like this: A equals F net over m. So small masses will give you larger accelerations given the same net force. Now, what is net force? Well, we've been calling it the sum of the forces or resultant. So net force is the resultant, or the sum of the forces, all the same, resultant. Okay, so m is mass, and it's measured in kilograms. So if I'm going to find the accelerations of these boxes that, by the way, are on a surface that has no friction, which makes them really simple. That's what this means. If you see mu equals 0, there's no friction. Now, what is mu? It's a roughness number. Mu equals 0 is this is a smooth surface. So let's apply Newton's law. Newton's law says the acceleration equals F net over m. Now, what don't we have in this picture? We don't have in any of these pictures, we don't have the mass. How do I know? Because it's Newton's. But I hope you know that if we divide by 10, we see that this mass is 5 kilograms. Let me scroll down a little bit. This mass is 4 kilograms. Make that 4.0 kilograms. This mass is 10 kilograms. How do we find the acceleration of this first box? Well, acceleration is F net, and the net force on this box, because there's only one force on the box, is 10 newtons divided by the mass, which you said we'll call it 5.0 kg. Let's make all of these, give them two significant digits, 5.0 kg and 10. So you get an acceleration, 10 divided by 5, what's kilograms? It's 2.0 meters per second squared. And that's the first answer. All right, same thing too. The sum of the forces. Now, take a look at this force. It has a vertical component and a horizontal component. But the only thing that's moving this box is the horizontal component. Check it out. Let's do this. So it's part, let's see, part, I don't want to mess up that angle. This, let's write that down. Only the Fx moves the block. I think you could also say that it's very clear to you that, should be clear to you, that the sum of the forces in the y direction equals 0. There's no movement at all in the y direction in this problem. So what's moving the block? The sum of the forces in the x direction, the only ones that are causing the acceleration, equals ma, or the acceleration equals sum of the forces in the x direction divided by m. I just rearrange the equation. So there's our equation. The sum of the forces in the x direction divided by m. It's getting a little crowded here. So what are the forces in the x direction? Actually, it's not 50. It's 50 newtons cosine theta, the horizontal component, which is the adjacent component, divided by m, which we found out. Remember, we found out the m is 4 kilograms. So you've got to substitute the 53.13 degrees that's given, and you get A is 7.5 meters per second squared. Let's go over this. This is different. So look at, again, this is a 50 newtons, and that's not our force in the x direction. We know that the sum of the forces in the y direction are 0. There's no y movement at all. It's all x movement. The only movement here is x movement. In fact, we can call this like that. There's only an acceleration in the x direction. So the sum of the forces in the x direction equal ax. Ax, the sum of the horizontal acceleration is the sum of the forces in the horizontal direction divided by m. How do I find the sum of the forces in the x direction? I take the x component here, divided by m, and there you go. Let's try another one. This one's really interesting. So we have, let's do our coordinate system, x and y. Now, there is no acceleration in the y direction, right? All the acceleration is in the x direction because we've called this x. Sum of the forces in the x direction equal ma(x). So the acceleration in the x direction equals sum of the forces in the x direction divided by m. Now this is not as easy as it seems. Now, next thing you have to do is establish, since there's movement, always call the direction of the movement the positive. If the box is going to move, we don't even know if the box is going to move. Why would I say that? Because I've got this upward force of 100, but what if there's a downward force greater than 100 that's actually going to move down the ramp? So let's check it out. What are the positive forces? Now we establish what's positive. We'll call up the ramp positive. So there's 100 Newton is a positive force because that's the 100 newtons. But now there's a negative force. What is the negative force? The force acting down the ramp. Well, the box is sitting on the ramp, on this frictionless ramp, and what would the force down the ramp be? That would be the parallel component, which is Fg sine 36.87. Is that greater than that 100 newtons? I don't know. I do know if it is greater, I'm going to get a negative acceleration. So let's see. F parallel equals 100 newtons times sine 36.87 degrees. That's my negative force, the parallel component. Remember, the parallel component is going to act down the ramp. So F parallel equals 60 newtons. So what does that mean? That's the negative force. Why? Because it acts down the ramp. Remember, we called up the ramp positive, and that's what you typically do, is you call the direction that you think the object is going to move positive and put the other direction negative. Now, if you're wrong, it doesn't even matter. So you just follow your convention. Now, divided by m. Remember, that's 100 newtons, so that's 10 kilograms. So that's 40. Oops. Let's come down here. Let's hide this. So it's AX equals 40 newtons divided by 10 kilograms, and that's 4 meters. Well, I could say, 4 meters per second squared. And there you go.